our lesson 9.1, which is over independent and dependent variables. Our objective is that we can write equations to represent the relationship between an independent and dependent variable. Now, in order to do this lesson, we obviously need to talk about what an independent and dependent variable are. So we already know that variables are letters that stand for unknown numbers or numbers that can change. And you can use an equation with two variables to represent the relationship between two quantities. Remember, quantities are just like amounts. They're two different things. One variable is called the independent variable, and the other is called the dependent variable. The value of the independent variable determines the value of the dependent variable. So what we're saying is that the dependent variable, whatever that number is, will depend upon the number of the independent variable. So for example, the cost of my gas, of all of my gas that I buy at the gas station, depends on how many gallons I buy. Or the cost of my fruit depends upon how many fruits I buy. So one value depends and changes based upon the other one. So let's go ahead and we're going to try and see how this will work in some questions. So we're going to look at this Unlock the Problem on page 491. So make sure you have your book open to page 491 and that you have a pencil sharpened. All right, so let's go ahead and read this problem. Jerry burns 5.8 calories for every minute she jogs. Identify the independent and dependent variables in the situation. Then write an equation to represent the relationship between the number of minutes Jerry jogs and the total number of calories that she burns. So we have two quantities here that we're talking about. The first is the number of minutes that she jogs. And then the other is the total calories that she burns. So both of those we don't know. It doesn't tell us in the problem how many minutes she runs, and it doesn't tell us how many total calories she burns. So both of these are going to be variables because they're both numbers that we don't know. So we can let C represent our calories. And we can let M represent the number of minutes that she jogs. The total number of calories depends upon how many minutes that she jogs. So her calories, the more minutes that she runs, the more calories she burns. The less minutes she runs, the less calories she burns. So the amount of those calories will change depending upon how many minutes she decides to run. So because the calories change based upon the minutes, the calories are a dependent variable because they depend on how many minutes she runs. So our C is going to be our dependent and M is our independent. So our equation would be the number of calories that she burns equals 5.8 times M. Because if we want to figure out how many calories she burns, we're going to multiply how many calories she burns per minute times how many minutes she jogs. So we can squish all of that together and put C equals 5.8 times M. And this represents the number of calories, C, that Jerry burns if she jogs M minutes, where C is our dependent variable and M is our independent variable. Take a second and make sure you have all of this down in your book so that you can look back on it later. All right, let's try another problem. So Lorelai is spending the afternoon bowling with her friends. Each game she plays costs $3.25, and there's a one-time shoe rental fee of $2.50. We need to identify the independent and dependent variable in the relationship. Then write an equation to represent the relationship between the number of games and the total costs. So let's go ahead and think. We have two things that we're talking about here. There's the number of games and the total cost. So how much she spends for all of her bowling. So I'm going to think which one depends upon the other. Well, the cost is going to change depending upon how many games she plays. If she plays more games, the cost is going to be more. If she plays less games, the cost will be less. So the thing that she can change is how many games she plays. So the cost is the dependent variable because it depends on how many games she plays. So the C, the cost, is dependent and the number of games is independent. So now we got to think, how can we write this as an equation? Well, we know our total cost is going to be our answer. So the cost equals $3.25 times how many games she plays. So we would have the cost times the number of games. But then we also have that shoe rental, but that's just one time. So I'm going to multiply the cost by how many games there are, and then I need to add on that $2.50 for the shoes. So again, we can squish all of these together to write our equation. C equals 3.25 G plus $2.50. This represents the total cost in dollars C that Lorelai spends if she bowls G games, where C is the dependent variable and G is the independent variable. Again, take a second and make sure you have all of this down so you can look back on it while you're doing your personal math trainer. All right, let's try a couple of these together. We need to identify the independent and dependent variables. Then we're going to write our equations to represent the situation and the relationship between them. Let's go ahead and read number 1. An online store lets customers have their name printed on any item they buy. The total cost in dollars is the price of the item, P, in dollars, plus $3.99 for the name. So we need to think which one depends upon the other. Go ahead and see if you can figure out which variable and which item is the dependent variable. All right, so we're going to think that the total cost depends upon the price of the item. So the more expensive the item is, the more the whole thing is going to cost. And the less expensive an item is, the less expensive the whole thing is going to cost. So the cost depends upon the price of the item. So we can write the cost depends on the price. The item. So since the cost depends on the price, the cost is our dependent variable. And if our cost is the dependent, that means that the price is the independent. And to write our equation, we could say the cost is the price, and says the price in dollars plus $3.99. So whatever the price of the item is, plus the $3.99 to personalize it and put their name on it. All right, we're going to look at number 2. A raft travels downriver at a rate of 6 miles per hour. The total distance d in miles that the raft travels is equal to the rate times the number of hours. So think about which one is the dependent and which one is the independent. So I'll read that again. A raft travels downriver at a rate of 6 miles per hour. the total distance d in miles that the raft travels is equal to the rate times the number of hours. Go ahead and see if you can identify our dependent and our independent. So think which depends on the other. All right, so I'm going to think that the distance depends upon how many hours they travel. If they travel longer, they're going to go farther. If they travel for a shorter amount of time, their distance is going to be shorter. So our distance, the total distance, depends on the number of hours that they ride. All right, and now we need to write our equation. So take a second and think if you can write what our equation would be. All right, so you guys know I like to write our equations in the order that I read them. So it says the total distance d, I'm going to write my d first, that the raft travels is equal to, so that tells me I'm going to use an equal sign, to the rate. I have to look back. What was our rate? So it says the rate is 6 miles per hour. So I need to do 6 times, now multiply it by the number of hours h. So D equals 6h. All right, we have one more that we're going to look at right now. And I know that these are confusing. So if you feel like you're a little confused, that's okay. This is the first time we've ever done this in 6th grade. It's the first time we've ever talked about independent and dependent variables. So we'll keep talking about it throughout today, tomorrow, and the rest of this chapter. So it's okay if you're like a little thrown for a loop. We're going to keep working on it and we're going to get it, and that's okay. All right, after that little pep talk. So number 3, apples are on sale for $1.99 a pound. Sheila buys P pounds of apples for a total cost of C. All right, so we're going to look and try and figure out which one is the independent and which one is the dependent variable. Our dependent variable, let's think which depends upon the other. Well, I'm going to think my total cost, how much money I spend, depends on how many apples I buy. So my cost, C, depends upon my apples, which is P. So our dependent is C and our independent is P. Now we need to think about what equation we could write to represent the relationship between these two variables. So let's go ahead and write them. And I'm going to think the cost equals the price per pound times how many pounds I do. So I have $1.99 times the price. And now one thing I noticed when I look at all of these equations that I wrote is my dependent is always by itself. So the dependent is the total. It's what it's going to equal when we do something with our independent variable. So we're either multiplying it or adding it or something is happening to that independent. So our answer is always going to be that dependent variable. It's the one that's on the outside. All right, you guys are going to have a chance to work on some of these problems by yourself, and then we will do some more learning on this tomorrow.